Right, in this one I'm doing actually quite a lot of stuff. I start to create graphics API functionality for creating and setting rasterizer state. Rasterizer state is if you have culling enabled or wireframe mode and different things like that. Also the ability to set viewport. And then also I go on to wrap up creating and setting blending modes. So by the end, I have a textured alpha blended quad rendering on screen. Quite a long session. This took about 2 hours to do. There's a fair amount of work because the raster state's got a load of parameters, and so does the blend mode, and I need to implement direct rendering API functions that wrap up D3D, the deferred rendering API functions that can be called from another thread and build up commands that D3D uses. So it's just a fair amount of coding, and it's actually quite nice just to sit down and churn out some code without having to really think about much, because I've already sort of done the design and got it working. But also it's just time consuming. One benefit of doing this process though is if I come along to port OpenGL to this graphics API, I won't have to implement the deferred rendering functions, because all they do is build up a command that gets passed to the direct rendering API, which is wrapping up a proper graphics API like D3D or OpenGL. So I only really have to do the direct functions for any other subsequent platforms, and then I get a multi-threaded renderer on any of those graphics APIs. So hopefully the power of the code I'm writing will have a better or a bigger impact later on, and for the time being it just means I've got to do this early stage and get the code written, basically. Here I'm just trying to make sure I've got consistent naming conventions, so all of the renderer creates functions create object states or objects, rendering objects that we use like textures or rasterizer state, blend states, and that's called renderer create. They have a renderer release function to free up the memory. There's a renderer set method which sets them, and I'm just sticking to that name convention so it's easy to remember and I know what everything is. Incidentally, in the future, the set function doesn't have to directly call the D3D set function. I could defer the D3D set shader resource or D3D set constant buffer or D3D set blend state till a draw call happens. So internally in the graphics API, if you do something silly like enable blend, disable blend, enable blend, disable blend, all you're doing is setting a flag or switching a pointer or something like that, and then when you actually dispatch a draw call which is going to have any effect on, then that's the time when it gets applied to D3D. So D3D now, D3D11 has nice things like it has a deferred and immediate context. You can use the immediate context from multiple threads. So some of this deferred rendering API might seem unnecessary, but OpenGL doesn't necessarily have this, or OpenGL ES on certain platforms can't be called on multiple threads, or different graphics APIs have restrictions of that they can only be called from a single thread. So this means at lowest common denominator I can always have a multi-threaded renderer, which is certainly something I want to do, because you can have if you have a single threaded game and it's entangled with your renderer, you've got 16 milliseconds to do your game update and your render. Whereas if you've got your renderer running on its own, you've got 16 milliseconds for draw calls. You could even create the command buffers on different threads if the updates and the command buffer generation was slow. So it just gives much more flexibility, and I think it's a nice design to be moving forward with this paradigm than just monolithic render update thread, which is pretty much, if you look at other people's code, and I certainly get to look at a lot of different people's code when I'm porting different indie games and stuff, and really everyone is in that mindset of just update render on the same thread. And we've had parallel computing for a long time now, and I think it's time that people really started shifting their paradigm and the way they think. And that was one of the whole ideas of this project, was from the get-go to make the engine massively multi-threaded or easy to parallelize, and that's what I'm doing so far. And I haven't even done any gameplay code yet. When I start to do gameplay, I'll start thinking of how I can distribute the logic onto multiple cores and how I can achieve massive amounts of throughput in this game. So hopefully I'll have large Boyd systems and loads of AI and stuff like that. Just build it up as I go along. As in one of the previous videos I did, I wrote a bunch of release functions to free up the memory. As I come to implementing new features, I am implementing a release function for them as well. So it's quite a lot of work, because for every D3D feature I encounter, I need to make a create function, a set function, a release function, and I need to duplicate those in the deferred and the direct graphics API. So just time consuming, like I said before. So here just putting some alpha into the sprite image, so I can check the blending's working correctly. And also I need to change the texture format from BGRA, from RGBA to BGRA, so it comes out correctly. And blending hasn't worked. Hadn't built textures, and there we go. So I've got a